Welcome to all of you. Today we will see what do we mean by functions. Okay. So you are familiar with function. Okay. So we'll see what do we mean by a function. So function is a relation. Okay. So we define a function. We define function. Let x and y be two non-empty sets. Okay, so x and y are non-empty set. Non-empty means what? It has at least one element. Okay, so a relation, function is a relation. Okay, a relation f from x to y is called a function. Is called a function if every element of x is related to unique means only one unique element of y. Okay, so that means what? Every element of x is related to one and only one element of y. So right, so if that relation satisfies this condition, then that relation will be the function. Okay, so then x is called domain and y means the second set. This is what? X is domain and y is called codomain of the function f. Okay, so x is called domain, and domain is very important. So domain decides the function. That relation is a function of not. Okay, and the types of the functions are depends on the codomain now. Right, so codomain will decide the type of the function. Okay, so whether that relation is a function or not, that will be decided by x. X will be decided whether that relation is a function or not. Right, so then what here? So x is domain. So that means what here? So we write this as what? F of x is equal to y. Okay. So here x belongs to x. Your y belongs to y now, right? So that means what? Here what? If you want to apply f on the element, you can apply f only on the elements of the domain. So x should be in the domain. Once you apply the f on the elements of the domain, then that will go enter in the then that will be the element of codomain. So that means your f of x, that means this is y, is the element of y. Okay, so now we'll see some relation and we'll judge whether that relations are functions or not. Okay, so that you will understand the definition of the function. Okay, so we'll write some Venn diagram. So suppose we have this. Suppose this is A and suppose this is B, and this is what f is given the relation. This is what 1, 2, 3, 4, 5, 6, 7. So this is A, B, C, D, E, F, G, H. Okay, so I will write this. Okay, so this is 1. Okay, so I will take another this. Okay, so this is your A, this is your B, this is your F now. We will write this is second. So this is a relation. Again F, this is your A, B. This is third type of the relation. So we determine whether that is a function or not. Okay. Okay. So this is a relation F from A to B. This is the relation. Okay. Okay. Suppose this is what fourth one. This is fifth one. Okay. Now check whether that relation, whether these relations are functional or not. Okay. So what is the definition of the function? If every element of A, so your X is here A, I have taken X as A. So no matter, you can take any. This is not depend on X, capital X and capital Y. You can take any two non-empty set. See here A and B are non-empty sets. Now this is a relation from F from A to B. Your A is the domain here. Your B is the domain here. Okay. Now see here, is it a function? What is the definition of function? If every element of A is related to every element, that means every element has an image in B. See, every element has an image in B. But what is the definition? Every element of A is related to one and only one element of B. So now here one is what? One is related to A and C. One is related to A and C. So that means what here? So I write this is what F1. I will write this is F2, I will write this is F3, I will write this is F4, and I will write this as F5. Okay, so these are the functions. F1 is not a function. F1 is not a function. Why? Because one is related to two elements of B. Two elements of B. So that means what? One is not related to one and only one element of B. So therefore it is not a function. F1 is not a function. For other, no problem here. 2 is related to only one element. 3 is related to only one. 4 is related to 5 is related to only one. Okay. So here what? 1 is related to two elements. That means what? 1 is not related to the unique element of B. So therefore it is not a function. What about this one? So here what? Here 1 and 2 are related to the no matter. This is what. So 1 is related to what? A. That means 1 is related to only one element of B. 2 is related to A. 2 is related to only one element of B. So no matter whatever the images of don't bother about the images of this one. So only one thing you should know that. So it should related to only one element. Here one and images of 1 and 2 are same. No matter. But one is related to only one element of B. Right? So 1 is related to only A. 2 is also related to A. So that means 2 is related to only one element of B. Only one element of B. So here what? 3 is related to only one element. 4 is related to 5 is related. All are related to only one element of B. So that means what here? F2 is a function. Okay. So F2 is a function. F2 is a function. What about F3? F3. So 1 is related to only one element of. 2 is related to only one element. 3 is related to only one element. That 4 is related to only one element of. 5 is also related to only one. But here what? 6 has no image. So what is the condition? Every element of A. So 6 has no image. That means 6 is not related to any element of B. So therefore it is not a function. So F3 is not a function. F3 is not a function. Why it is not function? Because 6 is not related. 6 is not related to any element of B. So therefore this is not a function. Okay. So now we check what F4. This is F4. This is a relation. So here what all the elements are related? All the elements are related to B. All the elements are related to B. So what here then? You see the one is related to only one element, right? So every element is related to B only, right? So each element has a unique image. So this is a function. F4 is the function. Okay, so what about this? Now here also, see here, how many arrows are there for each element? Everywhere there is arrow, and there everywhere there is a single arrow. Everywhere there is a single arrow, right? So that means what? This arrow means what? You have to write actually this thing, this thing. So I have not written this. What? You have to write this. What? That means 6 goes to 5, 6 goes to F. This is right? You have to write all these things. Okay. So this part. Okay, so same thing here for other thing, right? So that means what here? Only every element is related to one and only one element of B. So again, this one F4 and F5 both are the functions. F4 and F5 are functions. Okay. So now here what the domain is very important, right? For to define function, your domain is very important. Domain plays very important role in the function. Now suppose your domain is the set of the real number. Suppose your domain is the set of the real number. So domain is the set of real number. So this is your real line R. Okay. So this 0 is here, 1 is here, 2 is here, something like this, right? -1, -2 is here. Your codomain is also R down. The set. This is what? Also a set of the real number. And we define a relation now. So this is 0, 1, 2, 3 here, -1, -2, -3. Okay. So this is your this, R to R now. Your domain and codomain both are the grid. And if I define a relation F from R to R by f of x is equal to 1 upon x. Now is it a function? Is it a function? I have defined a relation like this. F of x from R to R by f of x is equal to 1 upon x. No problem with that. I have defined this one f of x. That means x goes to its reciprocal. 2 goes to 1 by 2. 3 goes to 1 by 3 and so on. So that means what? All the elements goes to the reciprocals of that. So is it a function? So what is the definition of function? Every element of this has at least one, not at least one, unique image in B. Unique image in B. In the codomain. That means every element of the domain has one or unique element of unique image in the codomain, right? So this is the definition of function. Now what happened here? Now let's see your definition. So your x is there. So if there is numerator and denominator, if there is a numerator and denominator, always think on the denominator. So check denominator. At what point your denominator is 0? If denominator is 0, then everything is undefined. Then that you know, you are familiar with this. Okay. So now at what point your denominator will be 0? So when your x is 0, then what? 1 upon 0 is not defined, right? That means what here? 0 is not related to any element of the codomain. So 0 has no image. So that means there is one element which has no image. So that means what here? It is not a function. So this is not function. This is not a function. But if I define like this, f from R to R, f of x is equal to 1 upon x, and if I mention this, x not equal to 0. If I mention this, x not equal to 0 here, so that means what? X not equal to 0. That means 0 is not in the domain. 0 is not. I have punctured this set. I have removed the 0 from my domain. That means I have punctured this the set of the real number. I have removed this point 0 now. So now see here, reciprocal of every number exists. Now this will be the function. Now this is function. This is a function. This is a function. Okay. So if I define like this, so then this will go. If I define like this, set of natural number to R now. So R is the set of it. If I define this, f of x is equal to, so if I define this, so natural number to natural number suppose. And if I define this 1 upon x now, if I define this, that means where is my x? my x is a natural number. My x is a natural number. If I define like this, okay, suppose instead of n, if in n is okay, so we will mention later on this. So what happens if you take n here then? Okay. So now f of x is equal to 1 upon x. Okay. Now here what? Here x is not equal to 0 is not given to you, right? But see what is your domain? Domain is the set of the natural number. So domain is the set of natural number. So 0 is not a natural number, right? Now see, reciprocal of every natural number is a real number. It is exist. Your codomain is what? It's a set of the real number. 1 by x is real number. So reciprocal of the natural number is a always real number, right? So here what x not equal to 0 is not mentioned here, but x is not 0 because 0 is not a natural number. 0 is not in the domain. Your domain is what? The set of the natural number. So that means what? This is exist. Your f of x is exist for all x belong to n, right? So this is the function. This is a function. Now see here. Here what? We have not mentioned x not equal to 0. Here if you not mention x not equal to 0, where your domain is what? The set of the real number. So 0 is in the set of the real number. 0 is here, but 0 is not here, right? So this is the meaning. So that means what? You must have to know your domain. You should understand here domain and codomain, right? So domain and codomain plays very important role in the function. So you should. So if I write this as, now what happened if I write this is 1 by n then, right? So natural number to natural number, if I define like this, f of x is equal to 1 upon x. Now see, you know that reciprocal of natural number is not a natural number. Reciprocal of natural number is not a natural. Only one is a natural number. So 1 is related to 1 only, right? All the rest have don't have the images, right? All the rest have, because reciprocal of 2 is what? 1/2, and 1/2 is not, is 0.5. It is not a natural number. So that means what here? The reciprocal of the natural number need not be a natural number, right? Reciprocal of the natural number need not be a natural number. So only one has an image here, but the rest of the natural numbers don't have the images here. So that means what? This is not a function. If your domain is this, then this is not a function, right? So if your domain and both domain and codomain are like this, then this will be not a function. Okay. So here what? Everything is depend on the. So that means what? You have to take the care of the domain actually if you want to define. So if I define this function like this, f from R to R, I will define the relation. First I will say this relation. If your condition satisfied, then it will be the function. So just I will say this is a relation. Define y. F of x is equal to 1 upon x minus 1, suppose. Okay. Or x square minus 1, whatever it is. Or x square, suppose x square minus 1. Okay. So now see, is it a function? Is it a function? No, this is not a function. Because if I put x is equal to 1, my denominator is 0. And if the denominator is 0, then everything will be 0. Right? So that means what here? Right? So for x is equal to 1, so 1 is the real number, 1 is in the domain, so it has no image. So that means this is one. Also there is a minus 1. Minus 1 is there. So square of the minus 1 is also 1. So that means what here? X not equal to what? If you mention this plus or minus 1, then it is a function. It is a function. It is a function. When this part is very important. X not equal to plus or minus 1. You are saying that x not equal to plus or minus 1. That means what? In the domain, your plus or minus 1 is not there. Right? So for other thing, you don't have problem. Your denominator will not be 0. No problem for this. Right? Don't take the care of the numerator. If numerator is 0, it doesn't matter. Okay? Okay. So now, if I define the function like this now, plus 1 here. So now see here, this is what? The square, x square is always positive. 1 is always positive. Sum of any two positive number is always positive, right? So denominator is not equal to 0 for any x belongs to R. So that means what? Whatever this may be here. So now if you define like this, f of x is equal to 1 upon x square, then it will be the function now, right? So because what? Your denominator will not be 0 for any x belongs to R1, right? For any real number, your denominator is not equal to 0. So that means what here? It is your function. Okay. So now similarly, if we define this what f of x, f from R to R suppose, and if this is what f of x is equal to sin x, f of x is equal to cos x, but f of x is equal to tan x. If you define this, if you define tan x, is it a function then f from R to R? So now what is the tan x? Tan x is nothing but a sin x upon cos x. Sin x upon cos x. So cos x may be 0 now. Cos x may be 0. So that means what here? At what point your cos x is 0? So note that. So see here. So this is tangent unit circle. So you know that trigonometric ratio are nothing but a point of intersection of the terminal angle and its terminal angle and terminal R of the angle and the tangent unit circle, right? So this is what, if this is what pxy, this is unit circle 1 0, this is what 0 1, this is 0 minus 1 0 and this is what 0 minus 1. Okay, and this x is nothing but what? Cos. Suppose this angle is theta, x is cos theta, and your y is sin theta. That means what here? What is this? This is the terminal arc of angle theta, and this is what a standard unit circle, and the terminal arc intersect to the standard unit circle at point pxy. Then your x is cos theta. That means x coordinate is nothing but a cosine of the angle, and y is nothing but the sine of the angle, right? So if you want to find a trigonometric ratio of any angle, just find a point of intersection of the terminal arc and the standard unit circle. You get the cos theta and sin theta. Once you get the cos theta and sin theta, you can find other trigonometric ratio easily, because all the rest of the trigonometric functions are depend on the sin theta and cos theta. Okay. Now here what? If this is the point 0 0 1. So here what? Your x coordinate is 0 only on the y axis, and if your x coordinate is 0, that means what? This is pi by 2. This is pi by 90 degree. Right? This is 180 degree. This is 270 degree. That means 3 pi by 2. See, for pi by 2, 3 pi by 2, 3 pi by 2, 5 pi by 2, they are the odd, right? Right? So that means what? Their terminal are directly on the y-axis, positive axis or negative y-axis, right? So the angle whose terminal are with positive x-axis and y-axis, right? Then the cosine functions are always, cosine functions of that angle are always 0. Okay? So then the trigonometric ratio, that means what here? Cos theta is always 0. If your theta, the terminal of angle theta, is directly on the y-axis, right? So any angle y-axis, positive y-axis or negative y-axis, then cos theta is always 0. Okay? So that means what you have to drop this pi by 3 pi by 2 on this, right? So then that will be your from your domain. So your what here x not equal to plus or minus pi by 2 plus or minus 3 pi by 2, right? And so on, right? So you have to drop that point from this, right? Then it will be the function there, right? So for this, your tan function does not exist, because tan pi by 2 does not exist. Tan pi by 2 is infinity, and infinity is not a real number. Okay, minus infinity is not a real number. That means what your tan function is not exist at this point. You have to drop this point from your domain. So you have to write this, right? Then it will function. I hope that you understand what do we mean by a function now. Okay. So now we also define what is meant by domain, codomain. Then what is the range of the function? Range of the function. Range of the function. Okay. So let f from x to y be a function. Be a function. Let f from x to y is a function, means what? Already x and y are non-empty set. No, right? So then range of the function f is denoted by r of f, and is defined as set of y belongs to x such that y belongs to y, not x, such that y belongs to y, such that f of x is equal to y for some x belongs to x. Okay. So you may also write this is what the set of all f of x, x belongs to x. That means the set of all images. Because of this is what, suppose this is x and suppose this is y. Okay. So then what, x goes to f of x now here. X goes to f of x. So f of x is what, image of x. F of x is what, image of x. That means what, you have to collect all the elements of the codomain which have at least one pre-image. Which have at least one pre-image. So that means what, suppose you have the function like this 1, 2, 3, 4, 5 A, B, C, D, E, F. So suppose I have defined this function like this. Okay. Now this is the function. Now see here D, E, F don't have the pre-image. They don't have pre-image. So they are not in the range. So then your range, suppose this is a function. Yeah. Then your range of F will be what then? So those elements have the pre-image. Only you have to take this one. Okay. So A has pre-image, B has pre-image, C has pre-image. So D and D, E, F don't have the pre-images. They are not in the range group, right? So that means what here, a range set is a subset of the codomain. Is a subset of the codomain. So that means what, in the range function you have to take the elements of the codomain. Elements of the codomain. So you don't have to take all the elements of the codomain. Only you have to take the elements which have the pre-image. So A has the pre-image, B has the pre-image, C has the pre-image. Only I have taken the elements of the codomain in the range function. Range function is what, the set of the images. Set of the images. So these are the set of the images. Okay. Now, when we say that choose equality of the function, equality of a function, of functions, equality of functions. So let f from x to y and g from z to w, suppose z to w, be the functions, be the functions, be the functions. Okay, be the functions. Okay. F is said, F and G are said to be equal function. Equal function. If one, so their domain should be same. Domain should be same. Their codomain is also same. Domain is also same. And second part is what? So your domain is said, that is what, x belongs to, x is equal to y, x is equal to z. Z. Okay. Such that then for all x belongs to x, for all belong to x, we have f of x is equal to g of x. That is what, every element has, and if you apply, so if you apply f and g on any element of the domain, then we must get the equal values, right? Then we say that these two functions are same. That means simply we write this what, f from x to y and g from x to y are said to be equal functions, are said to be equal functions if f of x is equal to g of x for all x belong to x, because domain and codomain are same here, right? So if you want to write a definition of the equality, I will write this definition of the equality, right? So right there, domain and codomain are same now. F from, so f from x to y and g from x to y are said to be equal functions if f of x is equal to g of x for all x belong to x. That means if you take any element from this, if you apply f and g on that element, right, you should get the same value, right? Then that function will be equal. Okay. So now, what do we mean by identity function? Identity function. Identity function. Okay. A function f from x to x. So for identity function, your domain and codomain should be the same. Okay. A function f from x to y is called identity function. Identity function if f of x is equal to x for all x belong to x. That means what? Every element is related to itself, right? Every element is related to itself, right? X is related to, so your x is related to x now, right? This is the image, this is your y is x, right? So this x is in the domain and this f of x is in the codomain. Because here domain and codomain both are the same here. So that means what? If every element is related to itself, right? So then that function is called identity function. Okay. So I think you understand what to mean by function. Okay. So we stop here.